This question involves using the intersecting chord theorem to solve a circle's problem. Now, the intersecting chord theorem works like this. When you have a circle and you have two chords that go through, they do not need to go through the center of the circle. We have chord AB and chord CD, and they intersect at point E. The theorem states that the distance AE multiplied by the distance BE will be equal to the distance CE multiplied by the distance DE. So that is this distance multiplied by this one will be equal to this distance multiplied by this one. It's a theorem that you will need to use, and it's one that is not given to you on the formula sheet in the examination. So looking at the question here, we have the two chords referred to here would be this one here, AB, but we haven't got the other chord. We need to extend this line DO so it goes right the way through the actual circle itself. So I'm going to draw that line on, continuing it on here. So that's going to be a straight line D to the opposite side. I might want to call that. What letter's not been used? Let's call it G. Okay. So I've got this line now that goes DG all the way through, intersecting AB at point F. Now, I'm not given the radius in the question, so I'm just going to let my radius be equal to R. So my diameter will be equal to, double that, will be 2R. So I know that DG equals 2R. Now, GF then will be equal to 2R minus 2. This distance DF is equal to 2. So I just take that away from my 2R, gives you my distance for GF. Now I have my 4 lengths, so I can actually use my intersecting circle theorem. So I know from the theorem that AF multiplied by FB will be equal to DF multiplied by GF. So AF is 7, BF or FB is 4, DF is 2, and GF is 2R minus 2. And you can see from here I have one equation with one unknown, so I'll be able to solve this and find the value of my radius. So let's tidy this up. I've got 28 equals 4R minus 4. 4R will equal 32. So my radius is equal to 8 centimeters. It's a nice little trick to work out the radius of the actual circle itself. So the next part of this question involves the secant theorem. It's represented by a diagram like this one. We have the line AB, which is going through the circle, and it's extended on, and it continues through, that continues out into space. DE is also in the circle, and that extends until it crosses the extended line of BC. So these extended lines are called secants, and AB then extends, DE extends, and they both meet at point C. Now, the theorem for this states that we have measuring from C, CB multiplied by CA will be equal to CE multiplied by CD. So this distance multiplied by the whole thing is equal to this distance multiplied by the whole thing. This theorem is not given to you in the exam. You need to be able to recall it under exam conditions. So applying that to the question we're looking at here, we need to extend out our line CO till it crosses the other end of the circle here. We'll call that point H. We haven't used H before. And we can see now that we have these two secants, AC, HC. And I can write down the relationships that we have there. So we have this distance multiplied by the entire thing will be equal to this distance multiplied by the entire thing. This entire distance is just the diameter of the circle, Our radius is 8, so we know that our diameter here is 16. So that's 16 centimeters here. And we're ready to go. So let's have a look. We have CB, which is 5, multiplied by CA, which is going to be 5 plus 4 plus 7. So that is this distance multiplied by the whole thing will be equal to this distance, which is x, multiplied by the entire distance, which is 16 plus x. Now let's kind of work this through. We've got 5 multiplied by 5 plus 4 plus 7. 5 plus 4 is 9, so that's going to be 5 times 16, which is equal to, what have we got? 16x plus x squared. 5 times 16 is 80, so we've got 80 equals 16x plus x squared. So we've got a quadratic here, so I'm going to make it 0 equals, just rearrange slightly the right-hand side, x squared plus 16x minus 80. Quadratics, you know, we can not usually solve. So what does that one become? This one works out quite nicely. It's x plus 20x minus 4. You can use quadratic formula, but you should be able to do that yourself. So x equals minus 20 or x equals 4. Clearly, you cannot have minus 20 as a distance. In this question, x is a distance. So clearly, that is not valid. So the solution must be x equals 4 centimeters. Quite a tricky question, using two different theorems that are not given to you in the exam. But the questions will kind of follow the same sort of pattern each time you see them.